Hello viewers, welcome to the session on pure learning in machine learning. Please make sure to watch all the prerequisite videos for your clear understanding and to make best use of it. Before jumping into pure learning, let's quickly recap Markov decision process. Markov decision process provides a mathematical framework for modeling decision making in situations where outcomes are partly random and partly under the control of a decision maker. Long story short, Markov decision process makes use of Bell equation and pure learning to make decisions from the current state to move to the next best state. Let's now look at the definition of Q learning. Q learning is one of the techniques to find the optimal policy in an Markov decision process. The objective of Q learning is to find a policy that is optimal in the sense that the expected value of the total reward over all successive steps is the maximum achievable. So, in other words, the goal of Q learning is to find the optimal policy by learning the optimal quality values for each state action pair. And the formula for this is given as quality with respect to the state and action is equal to reward of current state and action plus gamma, which is nothing but our discount factor, into the summation of probability of each state of current state to the next state and the maximization of quality of new state and new action. Let's discuss the formula more clearly in the upcoming slide. Before moving ahead, let's understand the algorithm that we use in Q learning. The very first step is to set the gamma parameter and environment rewards in the matrix R. Then we need to initialize the matrix Q to 0. After that, for each and every episode, we have to select a random initial state and then do while the goal state hasn't been reached, means we are starting the loop, and select one among all the possible actions for the current state, and using this possible action consider going to the next state and get the maximum Q value for this next state based on all the possible actions. And then we need to compute Q learning formula, and then we need to set the next state as the current state. After that we need to end our do loop here, and after that end our for loop. So moreover, the next algorithm to utilize the Q matrix is set the current state as the initial state. After that, from the current state, find the action with the highest Q value and then set the current state equal to the next state. After that, we are going to repeat step 2 and 3 until current state becomes goal state. And this algorithm will provide or return the sequence of states from the initial state to the goal state. So now let's understand it more clearly. For that, consider an example where we are having a house with 5 rooms, and the number 5 here represents the exterior of this room. So let us suppose So now let's understand it more clearly through visualization. Firstly, let us suppose that we are having a house with 5 rooms, 0, 1, 2, 3 and 4. And the number 5 here represents the exterior point of the house. Let us suppose we are having an agent who is inside the house, and our task is to make this agent learn the route map of this house, and he should come out of the house from any of the room. So the same situation can be represented in a graph something like this. So what does it tells? Here, if your agent is at room number 1, it can go to either 5 or 3 only, no other rooms. Similarly, if the agent is at room number 2, it can move to only room number 3. The same has been depicted here. And from room number 3, it can move to 1, 4 or 2. So, I hope you have understood the graph. So, our task is to make the robot come out of the room, and the main goal is to reach exterior of the house. So, for that, let's give the reward points. Initially, the steps which will have the reward are at state 5, where if you are already at state 5, there is no need, means it has been rewarded. Whereas the next immediate steps which may lead to evacuations, such as here from route number 5 you can move out, and also from room number 4 you can come out. So hence the states have been rewarded highest, that is 100. Now this same graph can be represented in a reward matrix as shown in this picture. So here we are having all the 6 states that can be possible, 0, 1, 2, 3, 4, 5, and also the action, means from this state to which state, what are the possible values. So in the reward matrix we are containing only the rewards. So the highest reward is given to stage number 5 to 5, means staying at the goal state only. And from 1 to 5, if the robot manages to come, then it is rewarded as 100. Similarly, from 4 to 5, which is nothing but 4 to 5. So for calculating that, initially we make the quality matrix, which will be initialized to 0. Every values will be initialized to 0 here, and we need to keep updating this quality matrix once the robot moves from one state to another state. Now let's visualize the working of Q-learning step by step. So let's suppose that our robot or agent is at room number 1. So all the actions which the robot can follow, means it is at state 1. So what action it can take to move to which room? So the possible values can be from room number 1 to room number 3, and room number 1 to room number 5. These are only the 2 possible values. So obviously, while applying the algorithm of Q-learning, how it calculates? It takes the reward of the state and action, the maximum of that, and after that we apply the gamma, which is nothing but the discount factor. Same the repetition of the formula of Q-learning, then max of the next state and initial all states. So initially, as we have already discussed, that our Q matrix is 0 initially. So at that stage, the values of 5, 4, 5 to 4 and 5 to 5 are 0. So the calculated value is reward of 1 to 5, means from stepping 1 to 5, maximum of this row and state, so which is nothing but 100 plus 0.8 into 0, which will come out to be 100. So our Q matrix, that is quality of the matrix, will be updated and it will come out to be 100 at this stage from 1 to 5. So now the robot has learned that if it is at room number 1, it will get reward if it moves to step number 5, state 5. Now let's suppose that our agent is at room number 3. It's a dumb machine. Initially at first episode it has learned that if it is at room number 1, then it has to go to room number 5. So now we have dropped the same robot in second episode in room number 3. So let's see. It can randomly move to. So what are the possible valid options that the robot can take? Means switching from one state to another state. What all are the possible values? So at room number 2, the from room number 3, it can move to either room number 1 or room number 2 and room number 4. Since here all those values are 0, so let's see how the quick learning algorithm works here. And our quality of matrix, which was updated in the last episode, is something like this. Now let's look at the formula. So at the same stage, randomly, let's assume that from 4, 3 or from 4, 2 and 1, it has opted by luckily to move to room number 1. And already we have seen that in episode 1, it has learned that if it is at room number 1, it can move to room number 5 directly. So the quality, if it has moved from 3 to 1, let's suppose, then its reward will be 0, as from room number 1 to 5 is reward from room to 1 to 5 is 0. Then the discount value is 0.8. Then the maximum of 1 3, 1 2 3 and 1 to 5 is 5, because we have learned from here. See, the rewards from 1 to the rewards value and plus state of the value to the maximum of 1 3 and 5 is come out to be 100. So discount factor into the value of 100 gives out to be 80. So our quality matrix will be updated to something related to this. So finally, after lots of episodes, that is training our robot with all the possible values, we will get finally something related to this, the quality index related to this. Then this can be normalized by dividing it with the whole value. See, it has been normalized, and after that we can have the plot of the same thing. Now here you can see, if our robot is state 2, then it has learned from all its Q learning that it will move to state 3 first. Then from state 3 it has to go to state 1, as its value 80 is greater than 64, or it can move to either to state 4 also, because both the values are same. So from state 3 it can either move to 1 or 4 randomly, and from 1 or 4 it has to move to state 5, which is nothing but our goal state. So this was a step-by-step and visualization of Q-learning algorithm. Hope you liked it. Finally, it's time for your favorite hands-on session on Q-learning in Python. So in this hands-on session, let's try to implement the same example that we have discussed in the earlier slides. First, I am importing all the important libraries. See, it has been executed successfully. Now I am defining the reward matrix here, the same as we have discussed in the numerical example. Let's execute this. Now you can see the reward matrix here, the same one. The fifth state is our goal state, and hence whichever state is going to fifth state is rewarded 100, the maximum value. -1 represents that it is not accessible to the state to go to that state, and 0 is the reward value. Okay, now I am creating a quality matrix also, same as that of size of that one, and filled with everything zeros. See, it has been executed successfully, and you can have a look over it. See, now we have to keep on updating the same matrix. The explanation has been done. Now here we are just going through the implementation. So the core algorithm starts here. Firstly, I have fixed gamma as 0.8 and alpha as 1, and all these variables has been defined. The number of states we are having is 6, number of actions which are possible are also 6, epsilon value, the threshold value has been kept at 0.05. See, let me execute this chunk of code. It has been executed successfully. Now that the robot can be in any of the states, so I am declaring a random state. See, it has been executed successfully. So for E is ranging from up to 1000 value. So I am taking for E in the range of int. I want to train my robot completely, so I have taken at most of 1000 values. So for E in this, what I am doing inside this for loop is just understand this line by line. I am creating a list of all the possible states. See the possible uh, states are 0, 1, 2, 3, 4 and 5. Similarly, now the robot can be in any of the state, so the agent can be in any of the state. So I am shuffling these states. See, I have shuffled it down. Now let's okay, after shuffling I want to put my robot in the first any of the random row. So my current state is now 2. From after shuffling the first value I am setting it as the current state. See, so the current state value is 2. Now the goal, I don't know whether it's a goal or not, so initially I am making the agent feel that it is not the goal. So for each and every episode what I am doing is, while it is not a goal, I am setting the all the valid moves that it can go from 2 to what all are the possible values where it can move. So further what I am doing is, wherever the value is greater than 0 in this matrix, these all are possible values. For 2 you see it is only one value, that is from 2 to 0, 1, 2, 3. So let's execute this one first. So it has been executed successfully. So our value move should be in a boolean value. See, it has been executed successfully. We can jump to 2 to 3. That's why it is true here, right here. So after that, understand this line. When we are going to execute, it will be completely clear for you. What I am doing is, here is number of actions feasible for that valid move. If it is below the epsilon value, and what all are, and I am taking the action. If it is true, then I am going to go to the next state and setting the next state as the action. Then after going there, just let me execute this line by line so that you can get a clear idea. So initially, see the actions which are possible from the current state, which is 2, is all these are possible, but I am interested in only in valid moves, so it can move only to the third state. From 2 we can move only to the third state, and if it is an integer, then our action, I am converting it into a 2-dimensional array. Let me execute. See, it has been executed successfully. I have converted it to 2-dimensional array, and after that again I am shuffling. If there were here, for example, for random state 2, it is having only one of the possible value. Let us suppose if there were 3 or 4 choice of rooms, then the robot, it's not then the robot have to decide. It can move to any of the room in the training period. So that's why let me show you that one also. For that, let me shuffle this again. F9. So I have shuffled. See, now we are in the third room, and from third room, okay, this is good one. Here we are having possibility of going to room number 1, 2 and 4. So let me try that one. Now current state will be the initial third row. See, it has been changed successfully. We are in current state 3. We don't know whether it's a goal or not, so I am executing that one. And now what are the valid moves? Let me see. The valid moves can be, see, room number 1, 2 and 4. And further I am creating what all actions can be do here is F9. See, all these are the possible actions, but the valid one actions are actions which I have to take are this one, 1, 2, 4. I can move from current state 3 to either 1, 2 or 4. So if one is here the action, if the particular action is an integer, then I am converting it into 2-dimensional integer. Let me execute that. Set of action has been done, and after that, after getting this, the robot can move to any of these three. Let's think randomly. It has gone to any of the room. After executing this, then the action is the very first room. Let's give it to it. So I want it to go to next state as 1. So for that I am creating the next state 1. Let me execute this chunk of code. See, it has been executed successfully. Now my next state will be 1. After this loops goes on doing until we come to this stage, where what we are checking is if my numpy sum hold the current states in the quality matrix. If the sum of that is greater than 0, then the action is the maximum argument of that matrix. Let me execute this chunk of code also, that so that you can understand. And after that, I don't want to allow the invalid moves, so just taking the random moves every time. Here we are taking the actions is equal to list of range of actions, and then again same state we are changing the next state, feasible state, same thing. So after that, after doing this all thing, what we are doing is we are updating our quality matrix. Once going from current state to next state, for example here the current state was 3, and from 3 we are going to next state which is 1. So 3, 1 will be passed and the action number will be passed. Action, initial action is 1. So after that alpha and gamma has been passed to update queue. Now let me tell you what we are doing. In update queue, what we are doing is we are applying queue learning algorithm, which is nothing but we are defining a function where we are taking the current state, the next state, and action and alpha gamma values. So these are nothing but the application of our formula, which is nothing but new updated quality matrix will be. We have applied the formula here, and after that we are updating my current matrix to the new random reward matrix, and then returning the reward matrix. Let's first execute this chunk of code. See, it has been executed successfully, and after that let's execute this whole chunk of code. If the reward, we are renormalizing the values between 0 to 1, means we are dividing whole with the maximum sum of the values, so the goal will be greater than 1. So whenever the reward is greater than 1, our goal will be true and the current state will be next state. Like it goes on until we reach the goal, or else the steps goes on increasing. So let me execute this whole chunk of code inside the for loop. Now see, it has been successfully executed. Now after executing, let me print you the consolidated quality matrix that it has calculated. See, wherever it is 1, the goal is reached successfully. So after that, I want to show the traverse for each of the row. Further, the traverse function have been defined here. So through greedy traverser for each state I, let me tell you the working. For example, if we are in room 1, so what all are the possible values? The current state is 1, so I am traversing the 1. The number of steps here is 0. We will traverse until we are going to the next goal state is 5. So, and the maximum number of steps I want it to try, the agent to try is 20. So after that, what I'm doing, I'm just changing the value from 0 to the next possible state, and current state I'm displaying this all thing. And let me execute this chunk of code for state 0 so that you can understand what I'm telling. See, from 0 it will move to 4 after training of the matrix. See, initially it was 0. From 0 it will go to 4, and from 4 it will move to 5, and we have reached the goal. So like this, after training of the matrix through quality index, it has executed for state 0. Now let's execute this for all the states. Further, let me uncomment this explanation. See, after that I am traversing this. Showcase is not defined. Yeah. Let me first execute this chunk of code. So traverse. See, it has been executed successfully. Now let's call this show traverse function to display the greedy traversal for each of the state. So, see, this is the final traversal for each of the state. For state 0, we have to move from 4 to 5, then 1 to 5, and you can cross check with our graph. And as usual, I have included code snippet for your fast revision. So you can pause your video right here and can take the screenshot of the same for your future reference. I hope this video proved fruitful to you and hope you have gained something extra than what you were knowing earlier. Thank you.